So yeah, I mean, thanks for the opportunity. We are here together with my colleague Juergen. So I'm Andrea Guglierame, I'm Business Development Manager at EXFO. And as already anticipated, we together with my colleague Juergen, we are gonna discuss and introduce the IP over the DWDM topic more from a test challenges point of view. So many of you probably already know, but well, for sure, most of you already know, but let's explain what IP over DWDM is. So in traditional architecture, muxponder and transponder line cards are acting as a clear demarcation point between IP and optical transport network. So they are used basically to interface with a client world, and they basically face towards the transport section of the network, and all the optical transport function are located in the line card itself. With the IP over DWDM approach, DWDM optics is plugged directly into the IP network element, like could be a switch or a router. So the consequence is that with this new architecture, with this new approach, IP and transport network are kind of merged together. This, of course, enables significant CAPEX and OPEX saving. So eliminating the transport line card and reducing the number of transceivers, and specifically the gray optics transceiver, contribute to the CAPEX saving, while the OPEX savings is achieved as a consequence of the reduction of the number of network elements, which means less use electricity and even real estate, actually. If you look at the current topology and technology used within a transport network, I mean, high-speed DWDM networks now are mostly based, when we talk about high speed in the long haul and metro core portion of the network, are based on optical coherent technology. Now, this type of technology with the first 40 gig coherent line card was launched in 2008 by Siena, and definitely, as we show in this chart, many progresses has been done through the years, mostly thanks to the advancement in component integration, miniaturization, which allowed a significant lower cost per bit, and reduced power consumption, and of course increase also the port density. Even if the IP over DWDM is not necessarily a new concept, this has been definitely been boosted by the advent of QSFP-DD, 400 gig ZR, ZR Plus transceiver, which enable a almost, I would say, seamless integration of DWDM coherent optics into a form factor which was already widely used in IP network element like switch and routers. So that's what really enable the concept and the growth of this concept of IP over DWDM. Now, the evolution is moving forward to even more compact and lower power consumption form factor like the QSFP 2800 gig ZR and higher speed like 800 gig ZR. So, as mentioned, in traditional architecture, the transport line card is acting as a demarcation point between IP and optical transport network. And the first challenge of IP over DWDM is that this clear demarcation doesn't exist anymore. Once you move the DWDM optics into the switch and router. And a converged management of the IP and transport network is now required. Other challenges are coming from the need to guarantee interoperability at different levels. Even more if an operator wants to maintain a fully disaggregated and open network approach. The first interoperability that must be guaranteed is host to module interoperability, which means the session really of the transceiver once it is plugged into the switch or router. Module to module interoperability is also very important if multi-vendor approach will be adopted. And then you need to take into consideration module to optical line system interoperability, which is also a very important factor. Last but not least, management of supply chain could also become a concern as operators have the option to purchase the DWDM transceiver from different vendors, which are not necessarily the same vendor, has a switch and router vendor and also optical line system vendor. So how to achieve multi-vendor interoperability is overall the key question to be addressed. Now we discussed about the different interoperability levels, but to make IP over the DWDM successful, host in general, any host must assure interoperability with multi-vendor of transceiver. And standardization activity has been completed by several standard groups, bodies like MSAs, like OIF, OpenZR+, in order to address some of the key aspects for this interoperability, specifically even host to module interoperability, like could be mechanical compatibility with the host, the standardized management interface. Power and thermal management is also very critical because for this type of transceiver, advanced power and thermal management needs to be taken in consideration, as the host has to handle transceiver with higher power consumption compared to the standard grid transceiver, which are typically used in this type of switch and router. Another important thing is the possibility to manage and operate the transceiver with different type of client and line operating mode, and even the possibility, for example, to tune the wavelength. Another important thing is the possibility to monitor the optical network performance from the IP network element, as now we should remember that the DWDM optics sits into the switch and router. So in order to verify the compliance of the transceiver to the different standards and to avoid module to host interoperability issue, then user have different tools, and I'm handing over to Juergen that can explain more in the details.
Yeah, thank you, Andrea, for the interesting insights of the challenges for IP over WDM. In this context, I would like to take up and focus on the CMIS, the Common Management Interface specification and its capabilities. So firstly, there is the multi-client and application support. But what is CMIS about? So CMIS describes the function of the module with the concept of the data path carrying applications. And the advertised informations are for the 400ZR host side interface. This is an 400 GAU8, so an 8-LAN electrical interface, as also shown in the host LAN count. Then we see the module media interface codes. These are generally defined in the SFF 8024. But like we see here, there are two codes for 400ZR, which are defined as amplified and unamplified. And accordingly to this, there's a various of codes for the OpenZR+. Here we find in total 14 codes. The 400ZR media, or also called line-side interface, uses an a single media lane, so one wavelength here. Then we have the power consumption and the thermal behavior. So the power classes, which represent an advertised range of the power consumption limits, and these are defined in the relevant hardware specification here. So for the thermal behavior, the transceivers are classified under 3 operating temperatures. So we have the commercial, the extended, or the industrial one. But as coherent devices are usually in a controlled environment of like data center rooms or network provider equipment rooms. So these rooms have an active temperature control and cooling systems helping to controlling this accordingly. So the pluggable operate at a relative stable temperature of around 50 degrees. But anyhow, the temperature monitoring verifies the behavior and confirms that the fluctuation don't exceed the allowed values here. Then further advertised capabilities are related to the wavelengths management. So the transceivers must be able to process the designated WDM channel or the channel frequency and confirm that the wavelength is locked. But here, depending on the case, this can also be further confirmed by a stability measurement based on a BER determination. But these items also are very important in terms related of the module to OLS, so optical line system, or the module to module interoperability. Then we have the optical power management, so for inclusive PDD or in OSFP, the transceivers are directly plugged in a router or switch, so leveraging higher output power. And with this, there can be directly access connected to the access or metro or regional WDM transport networks. And this is without additional intermediary interfaces and can with it eliminate the entire layer of the optical equipment and thereby significantly reduce both the CAPEX and the OPEX, as Andrea already explained. Then last but not least, we have the performance monitoring. So the optical metrics can be shown and verified. I will not mention and go through all the parameters here, but picking up the chromatic dispersion as a dispersive effect and also the DGD and other polarization-dependent parameters, as well as the optical signal to noise ratio. But beside this, we also can see and have the possibilities to show the link degradation feature. So this allows detection and also reporting for the 2 types of the link degradation. So we have first the FDD, so the detected degrade forward error correction, and also the FED, so the excessive degrade of the forward error correction here. So this link degradation is the monitoring on the media side or on the line side of the pre-FEC BER, and this is done over a performance monitoring interval. The next operability level is then from module to module. So here is to achieve a truly vendor-neutral solution and really breaking the vendor lock-in. The interoperability of the transceivers from multiple vendors is, so to say, a key element to ensure an open disaggregated network here. So different vendors plugged in a switch or router are configured to the same settings by the equipment using the CMOS registers. So such an approach is therefore also including the interoperability between the host and the module and to the optical line system. So that means the individual interop tests interact with each other and emphasize with it their relevance. But let me give you an example with the interoperability study of the OpenZR Plus during the ECO 2023 Plugfest. Here, 10 different transceivers were cross-connected in a matrix of transmitter to receiver combination. And yeah, the next slide then shows the corresponding measurement setup. So a noise-loaded link was used to characterize the penalties associated with the interop between the suppliers. And here the EXFO DCO-BERT application was to generate and, of course, evaluate the 400G traffic. And the next is the optical switch, which were located between the DCO-BERT and the noise loaded short link. This was to speed up and also automate the testing process here. But due to the insertion from the optical switch, the dynamic attenuator was adjusted and to ensure that the module input power was controlled to minus 10 dBm. And then first, the link was configured to have a high OSNR, so around 30 dB, to ensure that the OpenZR Plus loopback link was established. And at this point, the ROSNR test process began. So that means the obtained parameter was the ROSNR, so the required optical signal-to-noise ratio from the receiver. And this was used then for the performance metric. And the whole process was measured between each TX and RX combination. And here the traffic soak period was 30 seconds, and the noise step were incremented by 0.1 dB. And here the SA, so the broadband, the SA source was used as a broadband source, and the attenuator accordingly to increment in the step mentioned. So the data in the table were measured by the optical spectrum analyzer, and this after 30 seconds period of error-free traffic. And the test results in the table, so first the results in red, the vendor B results indicated multiple failure links. So these pairings had to be investigated, but were successfully operated accordingly. So as in summary of the RSNR threshold measurements, they meet the OpenZR Plus MSA requirements for the RX tolerance value. So here the required value is below 24 dB per 0.1 nanometer bandwidth. So this is following the MSA conditions. But however, 6 to TX, so transmitter to receiver pairs exceeded the tolerance values for the RSNR limit. with values ranging between 24.1 and 25.4 dB. And with it, back to Andrea.
Thank you, Juergen. And so as we discussed about the host to module and module to module interoperability. But as we said at the beginning, we shouldn't forget about the module to optical line system interoperability. It's true that at the beginning there was a lot of focus on the module to module and host to module, but really the module to line system is also a key aspect that has to be assessed and investigated. Some of the IP over DWDM links in fact will be or are greenfield deployment, but some of them will be brownfields. So different type of network architecture can be already deployed in the field, which would require the transceiver, the coherent transceiver to have specific performance in order to coexist with what already in the field. For example, we could have a point-to-point DWDM link or ROADM network, and the 400G coherent may need to coexist also with other type of technologies. So also different operating modes, like different FEC support or optical TX power capabilities, could be version with higher power. They can address different percentage of the link in the field, as the study from Siena here is showing. So a thorough study and testing in real-world networks is really required to properly assess the needed performance of the DWDM transceiver to maximize the adoption of IP over DWDM in the majority of the network link and topology. And Juergen, what are the, let's say, the best practice or scenarios that you have, let's say, to troubleshoot or assess this interoperability?
Yeah, there is also the mutual to line system operability. And this means that here in principle we have two ways to realize this. The ideally test is done by using a switch and router, as you can see currently here. But on the other hand, the reality is that this may only be possible to a limited extent, as the equipment may not yet be fully available. And this was also the case with the 400 setup pluggables. So that means that the initial test must be performed with the transceivers, the current transceivers, plugged in to the test equipment, depending here on which channel, if not all, has to be tested. The transceiver then first must be configured accordingly, which means the application selection, the grid, the TX power, and also the wavelengths or the channel. This remembers a little bit, and this is like repeating the host to module verification in this way. But to finish the further setup, the same procedure then has to be applied to the second tester for having an end-to-end testing, meaning that once configured, the BER then can be determined on both ends, and the assessment of the signal integrity can be made here. So for the most cases, we only need to verify and test that the BER is less than the predefined threshold, which means the number of bits required to accomplish. This will only depend on the required confidence level and the BER threshold. And the confidence level here is the percentage of the tests that the system's true BR, the bit error rate, is less than the specified bit error rate. But since we cannot measure an infinite number of bits, and it's really impossible to predict with certainty when errors will occur, the confidence level will never reach the 100%. So that means a pragmatic value here would be 95%, and this gives us a factor of around 3, by which the test time must be incremented. Then let's also see the ideal setup here. So in case that a switch or router is available, the DCO transceiver can then be directly used in the equipment, and then the corresponding test signal is then feed in with another port of the switch. So the principal BR measurement doesn't differ from it. So there's in that relation no difference. But we have to see that the results as such then relate to the interaction between the switch, the transceiver, and the optical line system. So that means, in other words, it will really include the whole system for testing here. So please,
Yeah.
Andrea.
So thank you, Juergen, for going through all the different interoperability levels. But let me address another point, which is supply chain, which is also very critical aspect. So based on a survey from every reading, over 65% of operators who responded say that they want to achieve multi-vendor interoperability. And of course, this arises few quick questions like, who is going to be responsible of integrating a new vendor, or making sure that the new vendor you qualify can be used and is interoperable with all the hosts, with all the line systems that you are going to use in your network. Another key point is how to manage field failure and RMAs, because clearly in the traditional approach, the critical portion of the network, which was the DWDM and Guglierame network, was coming together, and typically it was purchased by the same suppliers, the same vendor that was also supplying the DWDM equipment and maybe also the line system. So this really comes to another question, is that for operator, which is if they really can have a fully disaggregated or open approach, or they always have to pair transponder, routers, and transceiver from the same vendor. So in the end, it's clear that if from one side the IPoDWDM is bringing overall advantages in terms of CAPEX and OPEX, but more testing capability are required for operator to guarantee the multi-vendor interoperability. And it could be addressed in different way, whether outsourcing the activity to third-party company or with in-house capability. But always looking at the results of the survey, looks like 50% of the operators that want to pursue a multi-vendor approach are actually willing to build in-house testing capability. And Juergen, can you tell us what are the testing scenarios that are typically adopted to manage the supply chain in this specific case? And what are the tools?
Yes, thank you, Andrea, for related to the supply chain management. The related measurement could be based on an end-to-end transceiver testing system, which is some kind of a more complex scenario, but it's really suitable for covering the new vendor integration aspects. So depending on which insights then need to be gathered, the test then can be realized with either an DCO tester or an electrical layer 2 bit array tester. And here the main difference is that the DCO tester has an embedded transceiver slot to plug the modules, the to be tested modules, and where the setup with the electrical BERT tester uses an external MCB, so a module compliance board, and this approach of using a layer 2 BERT system could make sense when the number of pluggable cycles is high, so that in this case the MCB would need to be replaced when a degradation of the signal integrity is discovered here. So the total setup here shows a combination of an optical amplifier and tunable filter. That's like simulating the DMAX here, and also a variable optical attenuator. So this is really to simulate the impairments, the behavior of a link. And again, we see also here the SA broadband source to add additional noise, to also modify, to change the values for increasing or decreasing the optical signal noise value here. The other approach is then more suited for the field use. Though here we see the dedicated test suite with iOptics for the validation of the transceiver. And the focus here of this use case refers more to an reactive approach to, in that case, confirm field failures from transceiver for an RMA, for example. So iOptics is an automated application that provides quick and easy validation based on the test sequences. So we have here the I/O interface quick check, where it validates the I² interface and the hardware pins. And here this is a use of a sample of common commands and controls this applied to the corresponding optical device here. So the verdict by this test is in combination of the I²C interface test and the control and starter pin check results here. But the test sequence or the test suite itself also adapts the extended needs for coherent transceivers. So that means in particular, we have here the laser tuning test. So the minimum and maximum tuned frequency in terahertz, and also the highest and the lowest fine-tuned offset of the transceiver if applicable. Then we have the power tuning test, which validates the minimum and the maximum programmable TX power, which are advertised by the transceiver. Then the next test sequence is the optical arcs power test. So this is using the condition of the max and the min TX power adjustment. Then for the processing of the transceiver, the bit error test here, this reports the count of the bit errors and also the pattern loss status. So here there is a couple of test setups applied. So in detail, we have the nominal, the min power, then also the minimum bit rate, the maximum bit rate, as well as the measurement at the minimum and also the maximum wavelengths. So here the verdicts and the are gathered and correspondingly reported here. And the minimum power verdict is also reported when the TX power tuned test is succeeded accordingly. Okay, that is the supply chain scenario here. But now back again to Andrea.
Thank you, Juergen. Yeah, we are getting to the end. So as we mentioned at the beginning, front the gig is not the only player in the IP over DWDM story, for sure. I mean, we have seen 100 gig ZR is expecting to make a big contribution to the development and deployment of IP over DWDM, more in the metro access portion of the network. And definitely more vendors are expected to enter this market. Also at 800 gig ZR has already been introduced at OFC 2024, and that will be the next generation of IP over DWDM with very similar challenges to 400 gig ZR. Without forgetting that the industry is already looking at next generation. In fact, the OIF, for example, has already started a 1.6 tera project beginning of the year. So bottom line, just to summarize, the adoption of IP over DWDM, which is leveraging DCO transceiver, brings clearly CAPEX and OPEX reduction and saving, but clearly come with challenges related to interoperability, to network management, and supply chain. The industry, well, in order to mitigate and address all these concerns, this industry has made a lot of efforts to improve and guarantee the multi-vendor interoperability at different levels. I'm talking about standards definition, for example, CMIS, multi-vendor interop events, and I'm talking, for example, what we presented of the OIF Flagfest. But in the end, this means that in-house testing capability and expertise are required to support for operator a fully disaggregated and open IP over DWDM ecosystem. And I want to highlight the fact that EXFO, as test equipment solution vendor, has all the solutions that support the entire life cycle of a new technology development and introduction from lab to live. I want to thank you all for attending this webinar. You can find here our contact, so we are open and to answer your question, either in the few other minutes that are remaining or offline if you contact us directly.